Hello, and welcome to this edition of the Pulse on Power Show. I'm Ed Merkel, and we are pleased to present to you this series of videos designed to demonstrate the key features that you should be considering when selecting a power supply. Today's video will focus on our family of DC UPSs and why our unique design is the best choice in your control cabinet for any backup situation. A typical 24-volt DC UPS application consists of a control unit, two 12-volt batteries in series, a 24-volt power supply, and the connected load. Puls has taken this base concept and designed a truly innovative DC UPS controller that has several unique features. Puls DC UPSs only require one 12-volt battery for a 24-volt load, offering many advantages to the two 12-volt batteries connected in series. Cost, size, weight, and battery monitoring are just a few. All other competitive units use two batteries in series. Because of the single battery, the Puls DC UPSs provide a regulated output during the entire discharge of the battery during a battery event. All other competitive units follow the output voltage of the battery. Due to the sophisticated programming of the onboard microprocessor, the controller knows the state of health of the battery at all times and can signal when it is time to replace the battery. No one else can perform this task. Puls has taken our 24-volt DC UPS controller and added another feature. The Puls UB10.245 is similar to the standard DC UPS, and it fits in the same size housing. What makes this unit different is that it offers both 24 volt and 12 volt output. This 12 volt is perfect for applications that use radios for remote monitoring. We will demonstrate this unit today. As illustrated in the previous slide, the panel is laid out as such. Here is our dual output DC UPS controller, the single 12 volt battery, the power supply, the 24 volt load, and the 12 volt load. Before energizing the unit for the first time, the buffer time limiter and the end of charge dial should be set to the desired values. The buffer time limiter should be set to the time required to perform critical functions before the DC UPS shuts down. If the maximum time is desired, leave the dial set for infinity. For our video, I am setting the dial for 10 seconds. The end of charge voltage dial should be set to the temperature in which the battery is operating. We are at room temperature, so the dial is set for 25 degrees C. To make it easier to see during this demonstration, we will cover the light bulbs with this transparent material. Once AC is applied to the power supply, 24 volts is fed to the control unit, and the initial diagnostics occur to check if all is well with the battery and the wiring. If something is wrong, then the check wiring light will stay illuminated. However, if everything checks out okay, then the check wiring light turns off and the battery charging begins, which is indicated by the slow flashing green status light. The diagnostics of the LED are easy to determine as the indicators are printed right on the front label. The constant current charging method will continue until the battery reaches 85% of its charge, at which point the green status LED changes to a solid green. There is also a relay signal contact that closes when the battery reaches this charging point, and for this demonstration we have wired it to a light. Once the charging has reached 85%, the controller changes to a constant voltage charging method. At any point, if AC power is lost to the power supply, the controller immediately switches to battery without interruption. The green status LED changes to a fast flashing pattern, and the timing based on the buffer time limiter begins. The ready relay contact will open, and the buffer relay contact will close. Since these contacts are wired to indicating lights, the ready light turns off, and the buffer light turns on. Because our dial was set at 10 seconds, the DC UPS will shut down after this time has expired. At this point, the diagnostic LED shows that the buffer time has expired. Setting the buffer time limiter to the minimum setting required, preserves the battery charge, and prolongs the battery life. Once AC is restored to the power supply, the controller will start charging the battery for the energy that was used to operate the load during the power failure. For safety and maintenance purposes, there is an inhibit function built into the control unit that allows the battery to be removed from the circuit. If a 12 to 24 volt nominal input signal is applied to terminals 7 and 8, the unit will either not buffer when AC power is lost, or if the unit is operating on battery, the buffering will stop. To demonstrate this, I will flip the switch, applying the proper voltage to the inhibit circuit. If the AC power is removed, the control unit shuts the load down instantaneously with no buffering. However, if the unit is operating normally with the inhibit mode not disabled and the AC power is lost, normal buffering will occur. To stop the buffering, the inhibit is enabled and the load shuts down immediately. The inhibit function is indicated by the diagnostic LED. The battery will have to be replaced at some point, but knowing when is difficult to predict, as the number of discharges and ambient temperature can greatly affect the life of the battery. Puls has added a feature to the UPS which can indicate when the battery needs replacing. The replace battery contact will close when the internal program determines that the battery is not charging properly or is not holding the correct voltage. The process of determining a faulty battery takes about 24 hours, so a light is not wired to the contact for this demonstration. A simulated condition allows the diagnostic LED to show the replaced battery condition. Puls offers a variety of DC UPSs and 2 battery options, so please visit our website for more information. The advantages of the Puls DC UPS are that only one battery is required for a 24 volt load. This concept allows the longest battery life possible and prevents the need to find match batteries as replacements. A regulated output in buffer mode provides a more stable operation during the entire discharge of the battery. The replace battery contact can help determine when a battery needs replacing, which lowers maintenance costs. The small size and single battery can help shrink your enclosure size and lower transportation cost. Thank you for joining us. If you have additional questions, please call us or refer to our website where we have additional information on our products and applications. All of us at Puls would like to thank you for joining us today, and we look forward to seeing you on our next edition of the Pulse on Power.